Good day, everyone. We welcome you to today's webinar on advancements in polar climate dynamics by Professor Dr. Justin Sentian's groundbreaking research on tropospheric ozone and halocarbon variations in the Antarctic Peninsula. This session will be broadcasted later on at the Coastal Cities at Risk in the Philippines Facebook page. My name is Joshua Vidal. I'm the Transdisciplinary Research Associate for the Coastal Cities at Risk in the Philippines. Before we begin, please be guided of the house rules of today's session. The event will be recorded for documentation purposes. All guests and participants are automatically muted upon entry. For panelists, please keep your video off and your microphone muted, especially if it's not your turn to speak. For attendees, please send your questions, specifying to whom it is addressed to through the Zoom chat box so we can note this and raise it during our open forum. Let us now start the webinar with the welcome remarks from the project leader and the principal investigator of SICAR-PH, Professor Emeritus of the Ateneo de Manila University, Science Research Fellow of the Manila Observatory, and Science of the National Resilience Council of the Philippines. Let us now listen to the welcome remarks of Professor Emerita, Dr. Emma Porio.
Thank you, Josh. Good afternoon, everyone. Welcome to the webinar, Advancements in Polar Climate Dynamics by Professor Dr. Justin Sentian, groundbreaking research on tropospheric ozone and halocarbon variations in the Antarctic Peninsula. Dr. Justin, I've been very educated. I've been educated by your title alone, so thank you very much. I would like to thank Father Jojo Fong, Society of Jesus, the spiritual advisor of the Coastal Cities at Risk in the Philippines, for bringing us Dr. Justine here in the SICAR-PH and in the Philippines. Father Jojo Fong used to be the East Asia AAPI director, and that's how I started to get to know his work, because he asked our department to do a pastoral sociology course. So I'm very grateful that SICAR-PH is guided by a Jesuit that is committed to the Laudato Si and to basically promoting dialogue between science, spirituality, and integral ecology. So as you know, as I said earlier, SICAR-PH is a consortium of transdisciplinary research action researchers from the Ateneo de Manila and Manila Observatory, and our implementing partner, the National Resilience Council. SICAR-PH is committed to 3 principles of transdisciplinary action research. 1, we believe that to produce actionable science and consumable science with our people and our communities and stakeholders, we should co-generate our knowledge with our stakeholders. If we do that, we also co-create our capacities as scientists, professionals, and practitioners. If we practice these 2 principles, this will lead into co-ownership, co-stewardship, and co-benefits. So in this webinar, I will say that the effort, SICAR and, with Father Jojo Fong and other scientists like Dr. Faye Cruz, other practitioners and partners in the communities, we try to promote conversations between those who produce climate science and like Dr. Justine at the Antarctic Peninsula, and those who are trying to understand climate and disaster risks on the ground, as well as in policy making, in our teaching and research, and those on the community-based groups that are trying to create climate and disaster resilience initiatives. So I would like to thank Father Jojo, Professor Dr. Justine, for coming here and basically sharing with us their knowledge, and hopefully by creating this kind of spaces of engagement, then we can have a dialogue and a conversation in terms of how our different sectoral engagements, our knowledge production will find meaning in the way we create policies, in the way we design programs, and the way we design our curricular modules and the like. So thank you very much and welcome to our webinar. And we hope you'll always follow us also at the website of resilienceToolkit.ph, that the SICAR page produced that resilience toolkit for Philippine cities and other disaster risk resilience professionals and practitioners. Also, you can look at our website, the coastal cities at riskph.com. So thank you very much, and we look forward to further conversations with you and also collaborations. Thank you very much.
Okay. Thank you, Dr. Emma. To formally introduce our esteemed speaker for this session, let us hear from Father Jojo M. Fong, FJPDD, the board member of the Sacred Springs Dialogue Institute of Spirituality and Sustainability, and a member of Laudato Si Asia Coalition of Culture of Care, Resilience, and Ecological Justice.
Yeah, thank you and good afternoon. My gratitude especially to Doc Emma for welcoming this chance of collaborating, inviting Professor Dr. Justin Sentian, no? A friend of mine. We are proud to be Sabahans from East Malaysia. So, because he's also interested in what we call climate justice, there's a Archdiocesan Commission on Creation Justice, no? And therefore, he's also interested in creation spirituality. That's how we met. So I'm glad to present Prof. Dr. Justin Sentian from Sabah, East Malaysia, someone who has read his master's in atmospheric science from East Anglia University, UK, and obtained his PhD in atmospheric chemistry and climate change at the Lancaster University in UK. What is most interesting is he has presented over 100 papers in international and national conferences, seminars, and workshops. Above all, he has over 80 peer-reviewed research papers published in renowned international and national journals. What is most interesting to me is that recently he has done about 9 months of research during the winter season in the Antarctica, funded by the Sultan Mizan Antarctica Research Foundation. And therefore, today, I welcome him to share some of his insights and findings based on that 9-month research in the winter season of the Antarctica. Thank you and welcome.
Okay.
You may now share your PowerPoint, Dr. Justin. Thank you.
Thank you, Father Jojo and Doc Emma, for that opportunity to share some of the snapshots of the work that I'm currently doing. And towards the end of the presentation, you might be able to see a little bit of how the work that I'm doing very much related to the key issue that we are talking about, climate change. Yeah, right. And today, as Father Jojo mentioned earlier, by the way, everyone, can you hear me?
Yes, yes.
Great.
Just make your slide,
moving, yeah?
Yeah. Thank you.
So how is it?
Yeah,
Right.
fine. Perfect.
So the keywords of the presentation this evening or this afternoon is tropospheric ozone, which is bed ozone, which is located on the ground. And the other one is halocarbon. And how these two important species of gases or compounds in the atmosphere in the Antarctic, because these two play very, very important roles in atmospheric chemistry and, of course, climate. Yeah. So just a quick one. Don't worry about the words. There are too many words in here. I'm just saying that the surface ozone that we are familiar with, especially the ozone in the lower troposphere, is bad one. So we call it evil one because it's a secondary pollutants that can cause, affecting our human health. And also very important greenhouse gas, which leads to global warming or participating in climate change things. Now, this bed ozone, I would say, can also be transported to the lower stratosphere about 12 kilometers upwards, and vice versa. It can also go down, transported down to the lower atmosphere with these so-called STE processes, or stratosphere troposphere exchange. What I'm going to say here, this ozone, the bed one, can be become good, what we call it, after conversion, and become good ozone. The good ozone also can become bad when it's going down. So this is something like a little bit of religious thing. You can become a good, and you can turn from good to evil. Yeah. But interestingly, this tropospheric ozone, the one that is on the ground, or the first 10 kilometers from the ground, is greatly influenced by sunlight, and it's produced through photochemical reaction as well as the meteorological condition. So at least we have some ideas of this ozone. Yeah. And due to this extensive variation of this ozone on the ground, on the upper atmosphere, and it can also travel from tropic to the mid-latitude to the polar region, or vice versa. So the circulation of this ozone from all directions are moderated by climate change. On the other hand, it's also affected by the meteorological, and its impact is quite fantastic, huge, because, as I said, it is a pollutant. It can be a greenhouse gas. Now, the work that I'm going to show you today is a snapshot of the result that I have carried out in Antarctic Peninsula in 2 occasions. I've been there twice, one during summer, 3 years ago, and the second one during winter time, the longest one, about 7 months, actually, Father, not 9 months. Just ended last October. And it's located in King George Island. Now, this one is just set up the instrument. I think if you're interested, you can also always call me. Now, the first one that I would like to show you is that the ground ozone, the bed one, how it varied temporally. Yeah, so just from during summertime in December and January, and actually there's another one in February. Look at the red color for now. The concentration is just not that high. It's just about 5.5 ppb. Yeah, just keep that in mind, the value. Yeah, about 5.5 ppb. It's very low. And well, if you're looking at from the span of the time, about 2, 3, 4 months, well, you can see that there is a peak of high and low along the way. So but generally it's constant. Yeah, around 5.5. 2 years before that in 2016, another friend of mine measured ozone, not in the land, but in the sea. We call it the direct passage that is between the South America and Antarctic. And this is almost in the same month during summertime, warmer. But look at the value. In this open sea, it's slightly above 5.5, something mingling around 10 ppb. Yeah, so slightly higher. Take that in mind. Keep that in mind, because I'm going to show you another interesting figure. Now, years before, during austral summer or in summertime, there is a few other stations located in the eastern part of Antarctic, like Oshaya Station in the in the same peninsula. But there is one, that German station, Neumayer, Sowa, and Norris Station on the east part of the Antarctica, the red color over here. So they measure ozone at the same during summertime, what happened? Look at the one that I measure in King George Island at Great Wall Station is the one that shown with the black line at the lowest there, which is average 5.5 ppb. But look at all the other stations, the green, the brown, and what else? The blue, all are quite high, even above 10, 13, 16, 19, 22 part per billion. Meaning to say, even in the whole continent of Antarctic is so huge, there is also a great spatial variation of ozone. In the eastern part, where mostly land, the ozone concentration is much higher. The one in the island or in the peninsula is much lower. And that one can be explained due to meteorological condition, and it's of course surrounded by maritime environment because there is a very dynamic meteorological conditions over that side. So you can see the huge differences there. So in table, you can see the average like 5.46, while the others is above 10, almost double. So what that is one important finding, a significant finding that you will notice in the same conditions, summer months, yeah, in summer. Now, a little bit of analysis of why this ozone is lower in that particular station. So we did analyze, and we found out that the ozones that reaching in that place are greatly influenced by the maritime conditions and the meteorological. And it's not produced there, but it's actually transported from the far away from that source, so from the ocean. So that's the trajectory analysis. So meaning to say that the surface ozone or the bed ozone that we monitor there is not locally produced, but is produced somewhere else. And here, just showing you a quick one, the blue line is showing you the length of the air mass. That's meaning in the atmosphere, actually, there is an air mass that's actually moving from one place to another place. And we found out that the variability of this ozone is very much dependent on the air mass. That's mean how far or how long is the distance of this air mass travel. Yeah, so if the air mass is travel in a long distance, that means they have the ability to pick up a lot of ozone along the way. That's why the ozone is going to be higher. And yeah, and other things like the pressure, humidities, and wind, things like that. But the most important thing is the origin of the air mass, where it comes from, are playing very important roles in determining the ozone in Antarctic Peninsula during summertime. Okay, forget about this one. Now, 2 years later, that was last year, I went back again. Not exactly in the same station, it's just the nearby station and the Chilean stations. But the difference is I came during winter time. So last time was summer, last year was winter time. So I just want to see how the difference of the concentration of this tropospheric ozone in different season. So look at the value again. If you remember, the value of ozone during summertime is 5.5 part per billion, but this time it's much, much higher. It's can reach up to 35, 38 part per billion. Now, the big question is this particular greenhouse gas, the ozone, the tropospheric ozone, as well as a pollutant, why is it higher in winter time, where there is sunlight is very much less? Because ozone is a secondary pollutant that produced through photochemical reaction. But sunlight is less, but why ozone is a lot during this time? and the concentration is 7 times higher. So where it comes from? Now, so here is the comparisons during summertime and the winter time. The bottom is winter time and the upper one is summer. So the concentration is 7 times higher in winter. Now, second thing is that from the in-depth analysis of the ozone variability in that regions, there is one thing that very important factors is the presence of this halocarbon. 4 years ago, I didn't really look into this one, but we found out that through a number of studies somewhere that this halocarbon play important role in atmospheric chemistry, especially the ozone chemistry. So this time, last year, I returned to Antarctic to measure this particular halocarbon. Yeah, it might have something to do with halocarbon, because halocarbon, especially the bromine compound halocarbons, are very reactive in the atmosphere, participating in the reactions of the gases in the atmosphere that affecting ozone. Now, you might familiar with the ozone hole that is in the upper side in the stratospheric ozone, which is very much influenced by this halocarbon. This halocarbon is produced anthropogenically or naturally. From the natural sources, it can be from the marine and transported to the higher level, about 13 kilometers up there. And in winter, in September and November, springtime, it can, it will react with the ozone layer, the good ozone, and that cause the satellite detect the hole, the ozone hole. So meaning to say that the halocarbon that emitted, either naturally or human-made, are very crucial in determining this how big or the size of the hole. Because when we have a big hole, that means the UV from the sun might reach to the earth, melting the ice, and it can cause the volume of the water increase, and it might affect globally in terms of sea level rise. Apart from the temperature changes that might cause global warming, or the increase in temperature. So not just in the polar region, but every vulnerable country like us in Southeast Asia. And I believe Philippines have tremendous concern on this one as well. Now, in my investigations, I want to see how these bromocarbons emitted during winter time, because I want to find the answers of the linkages of this halocarbon, ozone, and in the later stage, the climate change. Yeah. So what we found that this halocarbon, I will show you the result in a while, a quick one, my preliminary result. We found that there is a huge amount of halocarbon stored in winter sea ice. When the seawater is frozen, the halocarbons that trap in the ice, when you it's quite high concentration of the halocarbons in there. And when summer comes, when the ice is melting, it will be released back into the atmosphere, and it comes to the normal pattern. So here results of the bromocarbons or the halocarbons that measured during winter time. So I have 3 samples here. Actually, I have 4. Another one is snow, but I haven't got that analyzed. So from the sea ice, for example, and the sea water and air. So what the thing that I want you to see here, in June, which is a mid-winter, and August or September, which is towards the end of winter. So the bromocarbon, the red color, or even the blue color, both are important. Both halocarbons are higher towards the end of winter. Similarly, in the seawater as well. But most important things that I want you to see is the value, the concentration is very, very high. Yeah, I did thousands of picomole in a liter of water. And just for your informations, previous study somewhere, not in this place, somewhere in the open sea, the halocarbon compound that they found is high, but not as high as this one. So the one that I found here is, I think, like 3 to 5 times higher than the one in the open sea. This one is in the bay. And on the right side, in the A samples, you look at the constant on the y-axis, the concentration of halocarbon in the atmosphere is very, very small. Meaning to say, during winter time, when there is no sunlight, most of these halocarbon are trapped. And they are either in the water, because this one is generated or produced by plankton, yeah, the biological processes, and trapped in the water or in the frozen sea ice. And it could also, I haven't got the snow result, but there might be an interesting thing to look at. Yeah, so this is the most important finding that I have seen so far. This is still a preliminary result. Yeah. Now, what is important here is that before I end this simple presentation is that we have the ozone in the produce, I mean, somewhere in the polar region. We do have the halocarbon. Both are important. Ozone is a greenhouse gas as well as pollutant. Halocarbon is very important because it's ruled as depleting substance to the ozone layers in the stratosphere. So when it's transported up 13 kilometers, 14 kilometers up there, it will, we call it, eat the ozone, the good ozone that create the ozone hole. And this ozone that exists in the stratospheric layer that's supposed to protect us will be depleted, and that can cause the ultraviolet from the sun reach to the ground and can cause secondary effect that affecting globally. Yeah, as I mentioned, melting of the ice, increase of sea level rise, and even playing roles in the photochemical reactions where the ozones at the grounds. So it's very complicated chemicals reaction in the atmosphere, but towards the end, these two important components that I can see at this stage is playing significant roles in climate change issues as well as the ozone hole issues that we have been talking all this while. So with that, my friends over there, thank you very much for your attention. But if you have any questions that you want to ask, I will very, very happy to talk about this. Back to you, Father Joe and Josh.
Okay. Josh?
Thank you so much to our speaker, Dr. Justin. Now, we would like to remind our audience that you can send your questions via the chat box on the Zoom, and you can also send me directly the questions to our speaker. At this juncture, Dr. Emma Porio will be spearheading the reaction session of our webinar. Thank you.
Thank you very much, Professor Dr. Justine. I am very, shall we say, excited about your findings. While you were doing it, I was saying, oh, so what are the connectedness of those, figures to the human activities that we do and the like. But anyway, before I get excited, I would like to say we're happy that we have two great reactors with us. We start basically with Dr. Renzo Argento, MD and Doctor of Public Health. He is Associate Professor of Global and Planetary Health at Sing Health Duke University and NUS Global Health Institute, and also with the Duke NUS Medical School, National University of Singapore. He's also visiting professor at St. Luke's Medical Center, College of Medicine, Philippines. He's also senior honorary visiting fellow at the Public Health and Primary Care, University of Cambridge. And I will not read all the other accomplishments and of Dr. Gento. It could take more time, but I'd like to say to thank Dr. Renz Gento because he's with us at the Climate Change Commission National Panel of Technical Experts. So thank you very much, Renzo. Dr. Renzo just moved to Singapore a few days ago, and I caught him and I said, please come and, comment on, on Dr. Justine's presentation, especially that, he's quite big on global and planetary health. Dr. Renzo, please.
Sure. Thank you, Ma'am Emma. And, it's so hard to say no to you because we've been working for the past 3 years together at the National Panel of Technical Experts of the Climate Change Commission. It is the national governmental body of the Philippines that really directs the climate policy and science in the country. So you can look at it as a mini IPCC for the Philippines, and I imagine other countries that are represented here do have similar bodies. And I'm starting my remarks with reflection on that because it's a body that is very transdisciplinary. Ma'am Emma is coming from the social sciences. I am coming from public health, looking at how climate change affects, the health of human populations. And in this day and age, if we are going to tackle climate change, we really need a transdisciplinary approach. So I think that's one thing that all the learners in this Zoom call should embrace and really appreciate. Thank you, Professor Justin, for that wonderful presentation. Admittedly, it is very technical, but also I think you made it really digestible for us who are coming from other disciplines. And I think that is something we need to work on. If we're going to drive transdisciplinary research on climate change and how it affects many different arenas of our society, of our civilization, then we need to find a way to communicate better with one another, right? So for example, if I'm going to talk about, diseases and I'll be very jargony about it, I will lose my audience, right? And I think, Dr. Justin, you managed to keep us hooked to your presentation. Also one reflection that I had is I've been wanting to go to Antarctica, as a climate and health scientist, or as a, Dr. Porio mentioned a while ago, planetary health. We're now looking not just at the health of people, but also at the health of the planet. I think as scientists and practitioners, we should be witnessing, experiencing, and observing all of these changes firsthand. I've seen a lot of different places already around the world, but never the Arctic and the Antarctic. So it's really in my bucket list. And maybe Dr. Justin, in your next expedition, let us know, and we might, establish a group, right, of a transdisciplinary group that will investigate how climate change is impacting the Antarctic, but also how changes in, let's say, how we manage our chemicals, right? You're talking about halocarbons, can destroy the Antarctic in return. I think it's a circular, relationship, right? And now I'll bring in the health part, the human health part. What's happening in Antarctica will surely be affecting the health of everybody elsewhere. Now I remember the closest I've been to the Arctic was in Tromsø, in Norway. They host the Arctic University of Norway, the highest university in the world closest to the Arctic. And what I found out is that in the Arctic, and I imagine it's similar to the Antarctic, a lot of the microbes that have been kept or stored in ice are now slowly being released as a result of the melting of the ice. And you also mentioned that the halocarbons, and I'm sure many other chemicals, they're all stored in ice that are now being slowly released because of the melting. So, these are important changes that can have massive implications for human health, also for animal health, because it's not only human beings that are exposed to these chemicals or to these microbes. Even animals, wildlife, which if they become sick, that can lead to future pandemics. Because many of these animals, wildlife, are carrying all these viruses and pathogens. And if we disrupt their behavior, if we disrupt their life and survival, it's likely that these pathogens will jump from an animal to a human being. And of course, we just survived COVID-19. We might see more of this in the years to come. So I think what I'm highlighting is that at the end of the day, everything is interconnected. You may be studying, Dr. Justin, very microscopic compounds, right? And how they are changing, manifesting, let's say, in Antarctic environments. But ultimately, it will affect people, animals, and plants, ecosystems, not necessarily in glacial or in polar environments, even here in the tropics, because again, we're all interconnected. Scientists are now saying that there are what they call this loops, right? Feedback loops that exist in many different parts of the world, and also tipping points that if we reach them, then we will be reaching points of no return, and that can lead to a wide array of catastrophic effects. You destroy the Amazon, you destroy the Coral Triangle here in Southeast Asia, you destroy the glaciers, right? And all of the above, and ultimately human health and the ecosystem's health will be in danger. So but I want to end this remark in a positive note. I think there's still hope. There's still hope that we can address these existential problems. History has shown to us that humanity has a way to, do a U-turn, to, improve their behavior, to change their behavior. There might be a role for, international legislation. Of course, the climate negotiations have been happening for the past 28 years. And how can we come up with better policy instruments that will really drive action that advances the health of people and the planet? And of course, I have finally very strong sense of optimism because of the young people, the next generation, who are studying these issues, who are working beyond disciplinary boundaries, who are breaking the silos, and who have a deep commitment to the future, again, to make sure that the future generations will have a healthy, environmentally sustainable, and just planet and world. Thank you.
Thank you very much, Dr. Renz, for that excellent remarks. Now we will proceed to the response of Dr. Faye Cruz of the Manila Observatory. Dr. Faye, thank you very much. I know you're very busy, and practically I twisted her arm to come and make comments. So Dr. Faye Cruz is a climate scientist with the Intergovernmental Panel on Climate Change. She's also the head of the Regional Climate Systems and Laboratory at the Manila Observatory, Philippines. The Philippine delegation to the Conference of Parties meetings have been very privileged to have Dr. Faye Cruz as its climate scientist. So thank you very much, Dr. Faye. I am very grateful that despite your busy schedule, you grant us your presence and your insights into this presentation of Professor Justine Sentian. Dr. Faye?
Thank you
Hello.
very much. Thank you very much, Doc Emma. I hope you can hear me okay.
Yes, thank you.
Thank you also to Father Jojo and especially to Dr. Justin for the very informative presentation. Good afternoon to everyone. So just to preface my reaction, as Doc Emma mentioned, I am a climate scientist, but this particular area, which is on atmospheric chemistry, is not really within my expertise. And so I'd like to thank our experts at the Manila Observatory, Dr. Obi Cambaliza and Dr. Liz Cruz for further insights as well. So as presented, we are concerned very much about tropospheric ozone and also halocarbons because of its health and environmental impacts as discussed by Dr. Renzo. But from a climate perspective, we are also concerned about its levels because it is a greenhouse gas and thus it contributes to the global warming, which its effects we are experiencing as today. And apart from being air pollutants, tropospheric ozone and halocarbons are considered as short-lived climate forcers. So what it means is that unlike carbon dioxide, which remains long in the atmosphere, these short-lived climate forcers have short lifespans, which lasts from weeks to less than 20 years, but they have an influence on climate. And depending on the type of aerosol, it could either be warming, such as in the case of tropospheric ozone and halocarbons, but it could also have a cooling effect in the case of sulfates. And so from what we've heard from this talk, there are still many questions that remain. There is still some uncertainty concerning these climate impacts. And so we very much welcome the research and work in monitoring and understanding this, as such was done by Dr. Justin. In fact, there's actually a whole chapter of on the short-lived climate forcers in the IPCC AR6 report. So if you want to know more about the current science and understanding about these short-lived climate forcers, I invite you to also look into that. Just to also mention that apart from, there are many initiatives, ongoing initiatives in understanding atmospheric chemistry, air pollution. And just early this month, we were involved in an observation campaign, which is called the Asia AQ, the Airborne and Satellite Investigation of Asian Air Quality, which is an international collaboration of NASA, the DNR, and also the National Institute of Environmental Research of South Korea. And we have had the privilege of, at the Manila Observatory, of also being part of this observation campaign, which aims to measure air pollution and air quality in urban areas. And so we truly will benefit from these research studies, as was presented by Dr. Justin, especially as we aim to limit global warming to 1.5 degrees or well below 2 degrees. And it's crucial that we do this in the next 10 years. We are unfortunately currently not on track. So there is interest in reducing these short-lived climate forcers because it will help us get back on track in the coming years. And so these findings help us understand more the complex interactions among these compounds, so we can find ways to reduce their concentrations. And this will not only limit their negative impacts on global warming and climate risks that we can face in the future, but also, as we have heard today, it also has the co-benefits of improving air quality and also has a good impact. The reduction of these tropospheric ozone and halocarbons will also be good for our health. So that's all for my reaction. Thank you very much and good afternoon.
Thank you very much, Doc Faye, and thank you very much also, Doc Renzo. Very excellent comments and responses that will allow us also to think. Josh, we may proceed now to the question and answer. And I think we have one question from Father Giorgio, no? But before I call Father Giorgio to basically articulate his question to Professor Justine, I would like to ask if there are clarificatory comments or questions from the audience. Or Doc Obi, would you like to, your clarificatory question for the speaker? Dr.
Good
Obi
afternoon.
Cambaliza, by the way, I'm very grateful to her, and her air quality team at the Manila Observatory because I really got educated with their work on PM 2.5 and other things. So Dr. Dr. Obiminda Cambalisa is the air quality specialist at the Manila Observatory. Dr.
Good
Obi?
afternoon, Ma'am Emma and everybody. Thank you po. And I'd like to just thank first Dr. Justin Sentian for a very interesting talk. And I was able to join a bit late, so I wanted to make sure that I was able to get the salient points. So basically, during your field campaign in the Antarctica, you were seeing lower numbers, like 5 parts per billion, on the order of 5 parts per billion during the summertime, but about 7 times larger during the winter time. I think I was able to get that. And then so when you returned, it was much higher, and it was during the winter time. I was usually if I remember my atmospheric chemistry correctly, tropospheric ozone is formed from the reaction of the oxides of nitrogen and volatile organic compounds in the presence of sunlight. So I was expecting higher numbers during the winter time, during the summertime rather than in the winter time. So my question is, do you have can you posit an explanation or a mechanism for why this could be the case, Dr. Sentian? That it's kind of different from usually in an urban environment. That's how it's actually formed, and and it's a secondary pollutant, so it actually forms in Metro Manila, for example. It forms a bit later in the day, when there's already sufficient sunlight for the reaction to happen. So that's my question, Ma'am Emma. So yun lang. Thank
Dr.
you.
Justine? Yeah, Dr. Justine, please.
Yes. Yeah. Thank you, Obi. I think I have the same questions with you in the beginning, because we thought in the urban environment, we also need these precursors for the ozone to happen. And normally it needs sunlight. But why in winter, when the sunlight is less or even no lights, suddenly the ozone is high? Where it comes from? So this is actually my research questions. And
Okay.
And I'm not even halfway of the investigations, but I know a little bit of that one. But I'm not saying that I know the reason, but I can guess something. But from the previous work that I've done in summertime, and it's depending on where you are on Earth, actually. What I notice here is that the transport of this ozone from somewhere, it's formed from somewhere, or it could be stored in some way, like some of these precursors are trapped during the certain time of the year when the weather is so extreme and things like that, and it's slowly released when there's a sun start and things like that. Then the reaction started. But that is just what very few scientists are talking about. That's why we are not really sure where it comes from. But 1, 2, 3, 4 analysis have found that there's two things. It's largely influenced by the regional or mesoscale meteorological conditions. It's not locally produced in Antarctic. It transported somewhere, and it could be from the ocean, it could be from South America, it could be from somewhere. That's another one. Secondly, it could be like produced locally, and it's probably because of course in wintertime it's not like 24 hours night, only in the mid of June where you're totally at night. But most of the time, I would say 70 or 80% of the time, you still have the sunlight. So meaning to say that there is still a chances of ozone being produced. Thirdly, but I'm not sure of this one. Actually, this one is my objective for the previous job, but I haven't really reached into that one. The STE, stratospheric tropospheric exchange. That means, yes, that's right. So it's transported from stratosphere downwards. And yes, a lot of possibilities, but I cannot give you exactly what the answers, but that is on the table.
Professor Justine and Dr. Obi, I always look at when you say anthropogenic climate change. So my question was, what are the human activities that are reconfiguring the interaction between the biophysical system and the social-cultural, climate, and economic systems? Because, as you said, they are coming from somewhere and they're moving. These things are moving. So I'm thinking we have to we have to find out what causes this from the biophysical system that's all there, and the anthropogenic activity, the activities that we human beings are doing that are harming these elements in the atmosphere. You know what I mean? So anyway, I know it's still early, but I'm always thinking about, so what can we do now? What is our role in increasing these halocarbons, these bad ones? What can we do to minimize the rising of these bad elements? That's all,
Yes, that's interesting questions, because from the anthropogenic point of view, most of this halocarbon, like everyone is familiar with CFCs, which is mostly produced in tropical belt or in the industrial countries or wherever from our region, but end up transported far away to the north, to the south, especially in the polar region in Antarctic, that cause these ozone layers. And this is where the connections within us living in the tropic and those that in the Antarctic, which nobody is in there. So meaning to say that the ethics, the human ethics or something like that, need to play important roles. Whatever things we do here, we make sure that we don't think that the impact is just limited in our region, but it's go beyond towards the end of the planet, everywhere, I would say. So it's very important that we have that kind of perspective.
Thank you very much. I would like to call on Father Jojo to articulate his question to Professor Justine. Josh, can you put the picture of Father Jojo, please? Okay. So, Father Jojo, can you please ask Professor Justine your question?
Yeah, Prof. Justin, I understand the importance of scientific research. At the same time, what we call the need for planetary ethics, to regulate. I'm just interested with my anthropological research on indigenous cultures and spiritualities. What is the role of, the wisdom of indigenous people and their local knowledges in terms of a transdisciplinary kind of research? Does one complement the other, or they're not complementary at all? Yeah, over to you, Doc.
Yes, this is very much pertinent things that I think we need to look at now. The indigenous people, for example, like us in the let's say mostly in the tropic region, and there is so many ways that in our daily activities that actually can be done, or we can interfere to ensure that certain species of these pollutants or the gases that can cause this global warming or depletion of ozone that originated from here. So for a very simple one, for example, if we are farmers, for example, in the rural areas, then we probably can, I think this is very interesting. deforestation issues, for example, because this forest is the one way of sequestrating, or what I call it, carbon storage naturally. We can store this one instead of emitting it into the atmosphere, because when you emit that into atmosphere, we don't have a control where this greenhouse gases, for example, or gas are going. It could reach Antarctic, or it could reach in the higher level of the atmosphere. So meaning to say, the indigenous people who are practicing mostly agriculture, I would say, the practice that these groups are doing, I foresee that it has to be carried out in more responsible way. Yeah, the way I look at it, like, and even I'm not saying that they are not responsible, even they are culturally things that they are doing much, much better than what we are expecting from them, because they are looking after their own ecosystem. They are looking after their own environment, like the forest and something like that. Just to give an example, I think Father Jojo, you should also notice in some part of Sabah, we do have this Tagal system. I don't know when Tagal in English for say, like, you're protecting the forest from being
river.
utilized.
Sure.
Yeah. So some communities, a number of communities are now moving into protecting their forests for not just for their normal dependence of their livelihood. They are not going for hunting and things like that, but just participating in the mainstream of protecting the earth. Like, they really now understand that it is good for carbon storage. Yeah. So this is where we don't even need to think of Antarctica to to what do you call it, to tackle this issue. Even at our doorsteps, we are having these indigenous people who are actually playing important roles, and I think we really much appreciated what they are doing. So what we need to do next is actually to enhance the awareness. Probably we need to go down and explain them in a different way, so that the effort that they already done many years can be solidified, and I think in line with the what we are hoping in the future, like, minimize the release of carbon in the atmosphere to avoid global warming. Yeah, I mean, that's my very crude
Okay.
argument.
Thank you. May I ask Bernard Lee to unmute himself and ask your question to Professor Justine? Bernard Lee, are you there? Hello?
Yes,
Okay.
I'm here.
Okay.
Yeah.
Please
Right.
ask your question directly,
Oh, sure. First of all, thank you so much for Professor Dr. Justine Sentian, and thank you so much for your excellent presentation and the detailed explanation. I'm from the business faculty. I'm just curious about the potential implications of what you have mentioned or explained, the advances in polar climate dynamics for ethical business activities and practices. And thank you so much again.
Yeah. Professor Justine, would you like to respond, or would you like also to comment on Tamrat's Waldemariam comments? You can read it there. He says
Yes.
about.
Yeah, I have read it.
Yeah.
Thank you,
Okay.
Bernard,
All right.
for that questions. Yes. This is very important to everyone, and especially to those business group, the ETEX. Remember that in the industrials, I'm not not this nation, in fact, even in the third world country like us, we are emitting this, for example, CFC, and which is controlled very well under this international treaty and the Montreal Protocol. And from the records, Montreal Protocol, which is signed by almost every country, has tremendous success to control this CFC. So this is part of the ethics, which we can't actually control this species of halocarbon from being emitted into the atmosphere. And fortunately, this particular species, like CFC, is from emitted from human activities or anthropogenic. That means we can do things. But the big challenges for us and also for the businesses as well is that how about those species that are emitted naturally, which human beings have no direct control, like the one that I just mentioned just now. So there is a key factors in here that interesting to link with the emissions of this particular species from the natural sources is the changes in the atmosphere, especially temperature, which is, we can translate it as global warming or climate change. Because when you heat up the atmosphere due to the global warming, that can accelerate the release of these gases from the natural sources into the atmosphere. And that can cause a secondary effect of climate change and whatever things that we can think of. Now, where we can, I mean, all of us can play, especially those from business community, is as outlined in the IPCC or from any climate forum, that we need to control those things that causing climate change, which is the carbon or the greenhouse gas per se. So I think we need to support what has been agreed in during the Paris Agreement, things like that, that we try to ensure that our planet is still within 1.5 degrees Celsius at the end of the centuries or something, or 2 degrees Celsius, by controlling or mitigating the emissions of carbon, which everyone can play, not just the businesses activity, but even every human beings, either they are in the rural area, whether they are in the urban area, or everywhere. So yeah, I think everyone has role and responsibility. Yes,
Exactly.
Are there other
Okay.
comments, burning comments? Otherwise, because we're running out of time, we would like to, I'd like to ask our panel reactors, Dr. Renzo and Dr. Faye, if there are any concluding comments or response before Father Jojo and I close the session. Dr. Renzo or Dr. Faye, do you have any, 2 or 3 sentences response or no more?
Yeah, I can start because I need to
Yes,
run
yes.
to another meeting.
No, I mean 2 sentences because
Yeah.
we're having that. Okay.
Well, thank you again, no, for this opportunity. I hope this will not be the last, no? And
No, beginning. It's a
there's
beginning.
so many issues that we need to tackle together. And the only way to do it or to address it is through transdisciplinary collaboration. Thank you again and take care, everyone.
Thank you, Renz. We'll see you next. And Dr. Faye?
Yes, well, Dr. Renz put it so very well. So yeah, there's still a lot of work to do. And so it's really important that we work together. So thanks very much.
Okay, thank you very much. Dr. Jojo, Father Jojo Fong, would you like to, say some concluding comments also?
I think the last comment of Prof. Justice is important for us, not that we all
Yes.
have to play our role as humans.
Yes.
Because we are part of nature. So Laudate Deum, the October 4, 2023 encyclical of Pope Francis asks us in number 25 to say that we are part of nature, included in it, and thus in constant interaction with it. No, so we are this human. We are humankind on this planet Earth, and therefore our anthropogenic activities have caused what we call the rise of temperature to 1.5. It is also mentioned that we're not managing it too well. Therefore, Dr. Renzi's point is also quite important in terms of our spirituality, our ethics, that we are all interrelated based on Laudato Si 138. Yeah. So we cannot say that we're not related to the Antarctica or to the ocean or to the atmosphere. We're all interrelated in that sense, and therefore what we do here on Earth does cause a ripple effect that is global, that is also cosmic. So in that sense, I think we really need to enter into a transdisciplinary kind of conversation, dialogue, research, so that at least we realizes that this God is asking us, to really pass on to the future generation a much more livable green garden. No, thank you.
Thank you very much. I really appreciate all the speakers. And as I said, our job really is to have a dialogue, to have transdisciplinarity in our work. And I think one of the things that really struck me is I like very much that Dr. Justine really put those, climate science, atmospheric terms into digestible, consumable. As I always said, in the coastal cities at risk, our job as Transfer Action Research Consortium is to produce actionable science, consumable, and that will lead to doable interventions and possibilities. So I'm very happy, and as I said, this is just one, this is really Doc Faye and Dr. Justine and Dr. Renz. This is one of our, I think, first actually, that Father Jojo and I initiated on trying to have what I will call, the interconnectedness between the biophysical and human systems and the different, climate regimes, risk landscapes, and the like. And I really feel that we should have this kind of dialogue between climate scientists, social scientists, humanists, theologians, philosophers, and artists. In fact, in the Ateneo Arete, we really think that we have to bridging science policy practice means transdisciplinarity and intersectionality in our practice. So thank you very much. I really appreciate, on behalf of our project holder, Father Roberto Yap, who is basically under his leadership, we're starting on a Laudato Si journey, a 7-year journey from 2023 to 2030 to becoming a Laudato Si University. So we can regard this as first of a series of the interchanges and conversations and dialogue, because it's only in sharing our knowledge and interacting with different knowledge systems that we may understand the risks that we are being confronted, and what are the possibilities for the imaginable future that we'll have together. So we will call on you again, Professor Justine, Dr. Faye, Dr. Renzo, and all the other participants here. We hope, we can start a continuing conversation, because
Can we have a group photo before we end?
Yes, that's right. Can we, Josh, can we please, all your videos so we can have a,
Merry Christmas, everyone.
Okay. Josh, can you please mute that somebody? Okay. So we will have, can you please put your video on, Leia, Mary?
Everyone, to those who can open their video cam, please turn it on.
Yeah, please, Elmar and Devin, because we'd like to really,
Ma'am,
start.
di ko open. Sorry, ma'am, di ko open kang camera ko.
Okay, that's okay. We know your name. Is Dr. Masagka still here? Hi, Dr. Jimmy. So I'm very happy that you're, from different parts, as Renz was saying earlier. We're coming from different parts of the ASEAN, and I hope we'll continue this. In fact, Josh, my research associate, is in Jakarta right now. And, all the other people are in different parts, so we'd like to start this. So, Josh, can you take the picture now?
Okay, and a count of 3, 2, 1.
Yeah. And for those who will be needing certificates, just write to us, Josh, no?
Yeah.
Some of you will be needing certificates of participation. Yeah, we'll do that. So thank you very much. We will meet again. We'll announce in our Facebook page all our activities for Gender Month, and also look at our websites. And in fact, this coming February 29 to March 2, we will have our exhibit and conference on anticipatory technologies for climate and disaster resilience. We'll announce it in our website also, okay? So thank you very much, and write to us. If you are interested in joining our webinars, so write to ccarph@ateneo.edu. You can also go to our resilience-toolkit.ph and you can see there how to contact us and the like. Okay. All right. Thank you very much. Thank you, Dr.
Thank you.
Friend.
Thank you.
everyone.
Thank
Jojo.
you. Thank you,
Father
everyone.
Jojo and Dr. Justine. This is a
Thank you.
start of an ongoing conversation. Okay.
Yeah, sure. We could talk again. We
Okay.
meet somewhere, somehow.
Yeah. Okay. Thank you very much.
Okay.
Thank
Thank you very
you.
much.
Thank you,
Thank
Sister
you. Bye-bye.
Lerma. It's nice to
you.
see all, like Mark Gister is there in Chulalongkorn, and I asked him, how did you get to know it? And he says, you know, he's from the Office of Civil Defense, but he's doing his studies at Chulalongkorn. So it's good, you know, keep track of us and write to us if there's anything you'd like to, you know, to hear or would like to, you know, promote. How can we promote the dialogue? How can we promote the conversation? Yeah. All right. Thank you, Father Jojo. Oh, Father
Father
Jojo, you're
Jojo.
muted. By the way, we're going to have on March 20, we have, I will announce on the website all our Gender Month activities. Also, like, for example, tentatively on March 22, we will be having a concert with Joy Ayala and, you know, with Pauline Salvano Bautista, who's teaching the course on LST. And by the way, we will be a concert focusing on systems thinking and climate justice. Okay, so we're experimenting different modalities of learning, arts, lectures, and other kinds of methodologies. Thank you.
Yeah, from
Okay.
ASEAN also, Mr. Tamrad Wadimariam is actually from Utopia.
Oh, wow.
Yeah.
Thank you very much. We will put this in our YouTube channel, the recorded. We'll edit it, of course, and then we'll do it. Okay.